Hi guys, welcome back to another video. And in this video, I'm going to be talking about what DHCP starvation attack is and how you can implement the code to DHCP starvation attack in Python. And in the first segment of this video, I'm going to be talking about basically what DHCP protocol itself is, how does the protocol work, what does the protocol do, and I'm going to be discussing a mechanism which is called the DORA process, which is used by the DHCP protocol. So let's get started. If you know what these things are, what DORA process and DHCP uh, protocol itself are, you can just skip to the coding part. But let's get started with what DHCP is. So DHCP basically stands for Dynamic Host Configuration Protocol. The next obvious question would be, what does this protocol do? So this protocol is basically responsible for addressing different devices in your network, basically giving out the IP addresses. So let's assume that you have got a new device and you want to connect it to your home Wi-Fi network. So basically, the only thing which you do is supply the password, and then you enter. And if the password is correct, the device gets connected, and then you can use whatever websites you want to use. So basically, there are a lot of things which happen behind the curtains automatically. One of those things would be assignment of IP address, right? So I could show it to you right now, or if I could open CMD. I'm actually connected to my home network, which is Vortex right now. So if I do IP config, you could see I have a local IP address. So basically, this task of giving out a local IP address to devices connected in the network, this task is handled by Dynamic Host Configuration Protocol, or DHCP. So this is what DHCP is basically, and I mentioned something called as the DORA process before. So what is the DORA process? DORA process is basically a process which is used by the main mechanism of DHCP protocol. Just like in TCP, we have the three-way handshake, which is basically SYN, SYN, ACK, and ACK. Here we have the DORA process, which is basically a four-step process, and the DORA is basically the acronym for which is used for each step. So the first step is discover, second is offer, third is request, fourth is acknowledge. So what is this process is basically used for assignment of IP addresses. It's basically the most essential and the most main process in this protocol. And if I have to give you a gist of DORA process itself, it could be something like the first packet, which is the discover packet, is sent by let's assume that this is not a malicious user but a normal user, and let's just ignore this multiple spoof discover packets. I'm going to be getting into this later, but let's just, for the sake of simplicity, to understand what DORA process itself is, let's assume this is a normal user. So the first step that would happen is basically this normal user. In fact, I could just change this. I don't mind that. So let's just get rid of this and get rid of this for now. And yes, so this is a normal user. So the first step that would happen is basically this user would broadcast to the entire subnet. It would broadcast, very importantly, a discover packet, something which is called as the discover packet, to the entire network, basically asking for an IP address. And then what the DHCP server would do, it would respond by an offer packet, which would also be broadcast, which would basically is a protocol of a way basically a user, a unassigned user, and a DHCP server talk. The third step would be the request package. Basically, the user would be requesting, that would be a unicast. The request packet would be a unicast message which the user would direct towards the DHCP server, basically asking for that IP address which it received in the offer packet from the DHCP server. And then the last message is the acknowledged message, which basically the server unicasts to the user, basically confirming this exchange basically, and leasing that IP address out of the IP pool which the DHCP server has. So if you understood this, you would basically get an intuition of what we're trying to do over here. We're trying to starve the DHCP server out of all the available IP addresses. Basically, we are going to be sending, as I had mentioned here, multiple spoofed packets. So I can just write in malicious again, malicious user. Yep. So now the malicious user would be sending multiple spoofed discover packets. So basically, what would happen then is the DHCP server would, for each time, it would reply with an offer packet and that offer packet would contain an IP address basically. So what would happen is, let's assume there are a certain number of IP addresses, right? Like every device which is connected to a network has to have a unique IP address, right? So if I just open CMD again, you can see over here, this is our gateway and this is our IPv4 address. So you would see that 192.168.29 is common, so we only have 3 spaces which equate to 254 IP addresses, right? So if I somehow basically by sending multiple spoofed discover packets, if I basically get allotted all of those 254 IP addresses, let's assume then there is a new device which wants to connect, but there would be no new IP addresses left. So you get the point. This is basically a DHCP starvation attack, so that the new user, even if he enters the right Wi-Fi password, he wouldn't be able to connect because there is no available IP address, right, which it could be leased basically to get into the network, right? It's not possible to get into a network without any unique IP address. So basically that's what we're trying to do. And very importantly, I've mentioned that multiple spoof packets. So why did I mention spoof, and what does spoof even mean in this context? So the built-in kind of a defense mechanism against any kind of DHCP attack which DHCP servers incorporate is checking the MAC ID of the request which is being sent. So let's say this user has a MAC ID X. So if I sent a normal if the MAC ID wasn't spoofed, and if I sent multiple discover packets to a malicious user, which of MAC ID X, which already has let's say an IP address assigned to it, the DHCP server basically knows that this MAC ID X already has a IP address assigned to it. So basically this attack won't work. So very important keyword over here is sending in spoofed discover packets. Basically the MAC IDs of the MAC ID field should contain random MAC IDs. Basically that's what I mean to say, right? And I'm going to be using Wireshark in this video. So if you don't have Wireshark, then you can just install it, download it, and install it. Not much of a big deal. I'm also be going to using Dhcp, which is basically a tool to send in network, basically fragment network packets and send network packets to whichever layer we want. So it's a very handy tool. And if you have Python installed, you could just type in pip install Dhcp. This would do the job of installing the Dhcp package in your system. And yeah, that's it, I guess, for the theory part of the video. I guess I'm not skipping anything. Let me just recheck. Yes, I also mentioned I don't know why, but the structure of a DHCP packet, I thought it would be cool to look at. So I made a video about OSI model and related protocols. My previous video was regarding that. So I basically took this from that video. And it's just cool to look at. So this is what the DHCP packet is. And in fact, I'm going to be showing you, we'll try to capture basically DHCP packets right now. So let's open Wireshark. I already have it open, right? So let's just restart Wireshark and just remember to capture from, I assume you have just a basic knowledge of how Wireshark works and basically what Wireshark is, right? It's a network capture tool. So the first thing you should be sure about that you are capturing from Wi-Fi. So let's do one thing. Let's disconnect from our network really quickly. And let's apply a filter, DHCP, or let's do DHCP 6, basically with both kinds of DHCP v6, I'm sorry. And now let's start capturing. And now let's try to connect back to our network. Let's see what happens. So there you go. There is a request package. There are 2 request packages for some reason, 3 now. But now we are connected, and there should be acknowledge package also, which I don't see over here right now. But okay, let's just restart this. And basically I wanted to show you what a DHCP packet would look like. So let's just disconnect and try to connect again. So there you go, a request and an acknowledge packet. So basically, I don't know why, but DORA process has 4 steps, and the first 2 steps, the discover and offer, for some reason they are not captured by Wireshark. I don't know if you guys can do it. If you guys can also capture the first 2 packets, then please let me know how. But I could only capture the request and an acknowledge frame. Even though we are going to be developing or forging discover package, but we could even look at request package to see what's happening basically. So this is what our package is going to look like. So basically the only thing we need to change over here is in the DHCP frame, this message type should be 1, not 3 but 1, which basically means discover, right? So we are going to be using this packet as a reference. Of course it's a request package, but I told them just need to switch one value. So other things are same. We are going to be using this as kind of a reference packet, and we're going to be building our own packet and sending it onto layer 2 to let's see what happens basically. So before writing the script in basically writing a script in Python, I'm going to be using Scapy, standalone Scapy, and let's see, let's kind of see what's happening, and let's try to send a packet over here, right? Let's try to build a packet before we write a script about it. So I really hope you know just the basics of how Scapy works and how you can incorporate multiple layers in Scapy, right? I'm not going to be explaining that, at least in this video. Maybe in future videos I can make a video about Scapy itself in the future, but that's in the future. Let's come back to the video. So first of all, what you need to do is you see over here the frame. This is not something we should be considering. Let's just consider these 4 things. Basically, we need to have an Ethernet and then an IP frame, then a UDP frame, then a DHCP frame, right? So let's try to build this packet, right? So let's say our DHCP discover packet, and let's first start with the ether frame. And the ether frame, as you can see, we are only considered about, okay, this is the wrong frame. The ether frame, the destination should be broadcast and the source should be, basically we need to randomize this, but let's, for sake of simplicity right now, let's just send it with MAC ID, or we could just essentially randomize it right now. So the source would be rand MAC, which essentially means random MAC ID. And now let's type in the destination. Destination should be F3456, which basically is broadcast. So we are basically done, and also the type should be on 0x0x800. I think the default type for an ether frame in Scapy is 0x900. So we just need to switch it back to this. So type would be not x, not 800. So this should be the type. So our ether frame is ready. Now let's construct the IP frame. So the IP frame, I believe, we only have to consider 2 things, right? The version header, we don't care. Differentiated service field, I don't even know what this is. Flags, okay, the flags basically, even in over here I mentioned, 1 second. Okay, no, but the flag is something which we shouldn't consider. Basically, time to live, I don't think we should care about. Protocol, okay, we need to switch the protocol to UDP. So proto should be equal to UDP, and the source address and the destination address, we need to switch that. So source should be 0.0.0.0, and destination should be 255.255.255.255. So I think we have a IP frame also ready. Now let's craft the UDP frame. It's UDP, and now let's see what we have to do here. The source port should be 68. So basically this is just we are just crafting the packet, so it's nothing very complicated, very simple. So S port should be 68 and D port should be 67. So we just type that to be 67. And then we have the DHCP over here. But before the DHCP, I think we need to do another thing, basically boot P. So boot P should be, it's actually over here if you see, and I can't seem to find it right now. 1 second. boot p flags. So boot p should be equal to 0, but in our case it should be equal to 1, because I remember telling you this packet is actually a request package, but we are not actually making a request packet. What we are making is the discover packet. So we just took this packet as a reference, right? So we're just going to be switching some things, and one of them is going to be the boot p flag, and another thing is going to be one message area in the DHCP, the DHCP section. I'm going to be coming back into it, but this is essentially what we need to switch, right? So I'll just open it again. So yes, this boot p flag shouldn't be unicast, it should be broadcast, because we are making a discover packet, right? So the opcode over here should be equal to 1 instead of 0. So op is equal to 1, and of course we have to write in the chaddr, and this should also be equal to the random MAC ID. So random MAC. So you got that clear, and there seems to be some bug over here. I don't know why this bracket is here, but yes, the boot p, this is what the boot p frame should look like basically for our DHCP file, and then we just need to write in the DHCP frame. So DHCP, and over here we only need to be worried about the options. So I'm going to be showing you why I'm doing this in just a minute. So options, and in the options we basically type in the message type should be equal to discover. So it's basically kind of like an array, and over here the message type should be equal to type in message type, and that should be equal to discover basically. So discover, yes, so our message type should be discover, and there should be a bracket, I guess, yes, and just write end over here. So okay, there seems to be some kind of an error. So there seemed to be a problem regarding the code basically. So I just figured out that removing the proto is equal to UDP solved that. So I don't exactly know why that happened, but essentially this would work. Just remove the proto is equal to UDP, and then this would work. So we would have our DHCP discover packet ready. And why did I write the options is equal to message type comma discover? Basically we need to mimic this behavior over here. There are many options, but we don't need to be worried about the others. Basically the message type should be discover. So if you wanted to craft a request package, we could just write in request over here instead of discover, but we wanted to craft a discover packet. So we have this DHCP discover packet ready. So let's just try snooping it. So let's just see if it's working properly or not. So I'll restart my Wireshark, and let's just send it. So one thing you need to remember is you need to send this at layer 2. So DHCP discover packet and send p. Yep. DHCP discover packet. Let's send the packet, and there you go. A discover packet was being sent, and you could send many packets, multiple packets basically, and you can see all of them are being logged. So I did run an attack previously, that's why it says that this ID, this MAC ID should be different. But that's essentially what I was talking about in the beginning of the video, is basically there should be a different MAC ID, right, or else you get the warning. So I did run an attack prior to recording this video on my network. So this error keeps on popping up. Source MAC ID must not be a group address basically. So whatever. So this is basically how we send a packet. Now the only thing we need to do is now we need to write a Python script. So this would automate the process of sending in lots of packets. So let's do it, and then we'll wrap this video up. So I'll open up notepad or dhcp starvation.py, and now let's just first of all let's just import Scapy. So from scapy.all, so to import Scapy you don't write Scapy, you write scapy.all. So we import everything from it, and I don't think we should, or should we implement, let's not implement command line parameters. We could just hard code the number of packets we want to send in. So that's the only package which you need to import. So let's now just copy our dhcp discover packet. So let's paste this over here. So I'll just again go over what this packet is doing. So the ether frame, the source MAC ID is being randomized, destination is the broadcast destination, the type is IPv4. This basically compiles down to IPv4 type. IP source is 0.0.0.0, destination is 255.255 blah blah blah. UDP, the S port and D port are what we basically saw when we are trying to mimic a packet, basically mimic an actual DHCP packet. Boot P basically is a flag which we need to set to 1 if it's a broadcast message, and in case of discover it is a broadcast message. Let's say you were sending in a request package, so the only thing you need to do would be change this to request and change this to 0, and basically the destination should be the actual destination. So those are the things you would need to switch if you were making a request packet instead of a discover packet. So UDP and boot P is ready, and in the DHCP, basically in the options parameter, we basically pass in the message type is equal to discover, and this basically an end. Basically we just write the end, right? And now we basically send P, which basically sends on layer 2 the DHCP discover packet. And now I want to mention the interface also over here. So the interface here in Windows, in Linux it's very easy to check the interface which you're working with, but in Windows if you want to check the interface, you could just type in netsh VLAN show interface. This would basically show the interface, the Wi-Fi interface that's working on your device. So this is my interface, so I'll just copy it and I'll paste it over here. And the loop, I'll just switch the loop to 1, which basically it would keep on sending it. And let's just also switch the verbose flag to 1. So let's try running the attack. Basically, let's just refresh our Wireshark. Let's see if we are connected or not. We are connected, and let's try to run the attack. So I'll just run the attack right now. DHCP starvation.py. Let's see, it's running, and let's run the attack. And there you go. You can see now Scapy is sending in like thousands of packets per second to our DHCP server, which in our case, or in a general case, is the router itself. So what's happening right now is the router is basically assigning, it's going crazy, it's assigning all the available IPs from the IP pool to these forged DHCP requests. So another thing I want to show is basically, let's pick a random DHCP packet. Just ignore this warning because I had already run an attack basically, so this warning wouldn't come on your system. What I wanted to show is that in the Ethernet frame, the source over here is 7D9F something, but let's choose a random another MAC packet. The source over here is B045 basically. So this is basically the main essence of this attack. The source MAC ID should also be randomized. So there, as you can see, it has already sent in 60,000 fake DHCP discover packets as I'm explaining you this attack basically. So what this would do is, now if you try to you could run this on your own network, and now what would happen is if another device tries to connect, there would be some error regarding the IP addressing and the device would not be able to connect. So this is what basically a DHCP starvation attack is. So we could just stop this attack right now, and it almost sent in 100,000 packets, 92,000 to be more exact. So this is basically how to conduct a DHCP starvation attack. And there is also another kind of attack which is called the DHCP poisoning, in which you basically poison the DHCP server, and then you act as the DHCP server, and then you can extend that attack into a DNS poisoning attack. So the DNS server itself is poisoned. So that's a pretty advanced attack, and maybe I'll cover the attack in a future video. But that's it for this video, guys. And if you found this video informative, consider liking this video, consider subscribing to my channel, and if you have any comments regarding this code not working, or if you have any question regarding this video, if you did not understand anything, you could just comment in the comment box, and try to respond to your questions as soon as possible. But for now, thanks for watching this video, and the code for this program would be on my GitHub, and that would be linked in the description box below. So thank you for watching, and stay tuned for the next video. Bye bye.